I like to write stories rather presenting stuff. So, yep, Federica, we share the same name, beautiful name in my opinion. She introduced me already. Well, I am born in 1972. I look younger, but yes, I'm almost 53 years old. I'm passionate about IT since 1985. I started with PostgreSQL. I fell in love with PostgreSQL since 2006. 2007, we organized the very first PG Day in Prato, Italy. And I have a PostgreSQL and FreeBSD tattoo on my shoulder. So that's true. I believe in the project, and so I just inked my skin about it. And I'm proud member of PostgreSQL Europe. If you want to get involved in Postgres in Europe, just go to this website. The association fee is very expensive, just €10 per 2 years. So you can join and participate to the community all around the European Union, but not only the European Union, is continental EU. So also the United Kingdom is very welcome, despite what happened. So, and I work, yes, as a freelance DBA at Chemidata, is my company. DBA are endangered species, but we are still there. So if you need any help about all this sort of stuff, just get in touch, ask me. I'm very happy to help, in particular to escape from other RDBMS. It's a very pleasure to help you to move into PostgreSQL. Now, how to get in touch? This is my LinkedIn. Codeberg, I'm trying to move away from proprietary platforms, so I still have my GitHub account, but I'm moving stuff into Codeberg and more, less corporate stuff, honestly. I am on Blue Sky, I am on Mastodon, and this is my blog. I haven't written too much on my blog, but I'm recovering because it's very pleasant to have my own platform, not owned by somebody else. And of course, this is the QR code for shared feedback about the talk and everything. All right, so let's start with the agenda. We will talk about MySQL, of course, right? So, in fact, we will talk about the JSON and the advent of JSON, JSONB, how PostgreSQL works with this particular data type, and how it can be used for moving away from something else. So let's talk about some history. The land of SQL. If you are a fan of Gintama, probably you will recognize these slides. The land of SQL. A long time ago, the RDBMS was called that way. And then it came the NoSQL and the ban of the structured data, and the SQL language apparently fell into decline. But we have a jack of all trades, PostgreSQL, that still has the spirit of SQL. And we will talk about Yorozuya. Yorozuya stands for all odd jobs or some sort of that. So let's talk about JSON. Why JSON is our or Yorozuya? Well, JSON stands for JavaScript Object Notation, open standard file format data interchange, uses human readable text to store. Thank you very much. Before we had XML, SOAP, and all this sort of crazy stuff. I worked with XML before JSON came into the scene of the IT, and it was massively painful. And yeah, it was born out of this thing about removing Flash or Java or anything necessary for communicating in real time from browser to server. So how PostgreSQL relates with JSON? Well, the story starts very old. It starts around 2011, 2012, probably, with the version 9.2. The JSON data type appeared. Developers went crazy. So I wasn't so impressed, honestly, because it was just a new data type, but we had no functions, no way for doing anything else. We could store it, validate it, but at the end, we had to load it into the application and use the application functions for querying and manipulating. The real change started with the next version, Postgres 9.3, which added some helper functions, so we could query through JSON. And then Postgres 9.4 added the real game changer, JSONB, which is what we will talk about today. JSONB is the binary representation of JSON, and also added all the helper functions already present in JSON. And then a very long hiatus, so some improvements, but the real change happened with PostgreSQL 12. Recently, Postgres 12 went to end of life in November. Now we are on Postgres 17. And it was added the JSON path functionalities. And then Postgres 16 added JSON constructor, identity functions for testing the values within JSON. And finally, our last release added new capabilities, casts over the JSON data type for the single internal data types, and in particular JSON table, which is a massive improvement from transforming a JSON object into basically a virtual database table. So what are JSON and JSONB? Well, JSON and JSONB are just two different ways the data is stored into Postgres. With JSON, we have basically text. JSON is stored, validated on insert every time you read and every time you update something within the JSON object. So it's useful if you need to have something very simple, store your JSON, and then all the logic is into the application. But the storage space maybe is a primary concern because JSONB is slightly more eager in terms of space rather the JSON, but it depends also by the data structure. And you don't need any particular indexing, complex data querying or something like that. JSONB instead stores the data as a binary representation. It's just a binary encode, and the data is validated on insert and eventually on update. But on read, you don't need to do anything else. So it's very efficient for storing the data. You can use the helper function for accessing the JSON object within your JSON object, your JSON unstructured data. And also, you can also have a basic structural integrity. And also indexing. The indexing is the part I prefer the most, but I will show you how it works. Binary storage, so the JSONB has good binary storage and efficient querying and indexing. Indexable fast for data retrieval, rich query operator and functions, automatic data validation, and flexible schema for complex data. But the disadvantages. We have larger storage than plain JSON. Under particular conditions, the example I will show you, they are exactly the opposite. JSONB is way better, it's slightly better than JSON. It depends how the JSON is composed. It adds a little impact onto the writes if you have an index on top of it, and complex query of nested data. Unfortunately, most of the functions available in JSON, but also in JSONB, query the top level keys. It's slightly more complicated to nest and update the inner keys. The schema, yes, is enforced, but it's still weak. So if you want strong schema enforcement, don't use JSON, use tables. And there are some trade-offs for certain operations. In particular, when updating evenly nested keys within the JSON object, it can struggle to perform. So let's have a look at the Dragon of Katsurahama. Sakamoto and Mutsu. So how I proceeded for presenting you this thing. I loaded a significant amount of data. This is a very simple faker. It's just a Python script, very stupid. Creates two tables within the database schema, one for the JSON data type, is JSB tab, and the other one with JSONB data tab. That's it. I create a sequence just for having a counter or something like that. Is just professional deformation. Bear with me. And then with the faker, I loaded 5 million rows in each table to be slightly more performant, because the faker is quite slow when it's called every time. I just executed the fake every 1,000 rows. So we have 1,000 rows with all the same data repeated across the data. But it's quite good to show you an example. The data is written in this way. So we have a name, date, address, city, phone number, and the password full entry. That's it. And this is the storage for the data. If you see the JSON tab, it uses 1.45, 1,450 megabytes. And the other one, JSB, that should be the less efficient in storage, is using less storage because how is organized JSON impacts also how the data is stored and compressed as a binary. So all the text, are you familiar with explain, analyze? Not many, so I will give you just a very, very quick what this number means. Explain, analyze, put before the query, executes the query, and returns the timing for the query. So the first number here is in milliseconds, is the time for delivering the first row, and the second number is for delivering all the rows. That's it. So we have that this query, just a very stupid query, filtering over Thomas Green, is consuming 2.8 seconds and is working in parallel because Postgres has parallel execution. So it launches the parallel sequential scan on top of that. Very nice. And this is JSON, not JSONB. Now let's see how it works with JSONB. Wow. Half second. Why this difference? Because when you read JSON, the CPU is massively. Is eaten massively. So because JSON loads the row in memory, transforms into JSON, then validates. JSONB is not necessary because everything is already done at rest. So the read happens as an already validated JSON, and all the CPU churn is completely gone. So it's way faster to access the same kind of data. But I wanted to give you a third example. What if I create a text table? A table with the text field, and I do exactly the same thing, using obviously the operator like instead of the JSON operator. Well, in that case, even the text is slightly faster, 1 second faster than JSON. So the suggestion is, if you have to store JSON just for storing it, use text, don't use JSON. If you want to use JSON for doing what I will show you in the next slides, let's use JSONB. And this is what happens with JSON. We can also use this particular operator. This is one big class of operators to check to compare the status of JSON object against other JSON objects. In that case, this is a containment operator. It means the JSON name Thomas Green. Is it contained into data? Yes or no? And in this way, I get exactly the same performance, slightly different, but there's some fluctuation, than using the direct access to the key. Why I'm using this? Because this works extremely well with the indices. So let's put an index on top of my JSONB tab. The index has to be GIN. GIN stands for General Inverted Index. It's an inverted index. Keys are mapped to entries to the physical blocks. All the opposite of the B trees, where the entries into the B tree are mapped to the entries into the table. So it's completely reversed, and normally can be even bigger. It's very efficient for indexing vectorial data, unstructured data, geographical data, and so on. In that case, this index creates a very small index because the JSON is very simple, but it can be orders of magnitude bigger than the original table, the index. It's all the opposite. Normally, the index is smaller than table. With this index, you can get a larger index than the table. But the impact is devastating. It's half a millisecond now for doing the same query because it's using the index. But beware the impact over the writes, because the indices are good for read, but very bad for writes. So in that case, the gene index is even worse because the weird structure of the gene index, updating the gene requires a lot of updates, all scattered around the gene index. So just to give you an idea, adding the index, but it's possible to mitigate using this particular value that is the gene pending list limit. What does it mean? I do an update, the gene index doesn't get updated immediately. It puts all the updates into a non-indexed area called pending list limit, pending list, and then vacuum, when it processes the index, puts the data in the right place. This way, the index is way faster. How much is the impact? Let's see it. If I drop the index and I do an update, I can do the explain analyze on top of the update, but beware, because the data is changed actually. So I'm wrapping my explain analyze between a begin and a rollback for not changing actually the data. If I do this thing through any GUI interface, it's fine, because the GUI interface does this thing for you. But if you do this thing using PSQL like I'm doing here, beware. So the update on raw data, it takes 1 second, barely 1.1 seconds. If I add the index, so like before, and I do the update, explain, analyze, it takes 9 milliseconds, way faster, because obviously it's just finding the rows to update via the indexes, so way faster than sequential scan. But if I remove the index, and then I recreate the same index with the fast update equal off is a storage parameter. So I'm turning off that particular optimization. The time for the update is 77 milliseconds, 10 times slower. So beware about how your indices are configured. Now let's talk about JSONPath. JSONPath is the new functionality that allows you to access to the directly to the data into the JSON. For doing that, for showing you how it works, I just add the key childs to my data set using the function JSONB set. This parameter true, it means if it's not present the key, just create it and populate it. So updates 1000 rows. And this is the way for accessing the data. I just need to pass through JSONPath query, the data field, specify the path in this form, $.childs as childs, the parent, and also I can use into the where condition where the data has the key childs. I'm also doing a distinct because I have 1000 rows of the same data, so I don't want to show you 1000 rows altogether. In terms of performance, well, I left the index in place. So we are talking about retrieving this information over 5 million rows table, about 2.7 milliseconds. Still a very good performance anyway. Beware about the where condition. If I use this form, that is just a comparison operator, all fine. But if I use the JSONB exist, is perfectly legit, is a function for finding whether the data is present or not, well, the index is not used. Functions normally disable the indices. And then we have our JSON constructor. I can use a normal select to be fed into the JSON array function, and this will return me a perfectly valid JSON array to be used somewhere else. So I can also get my structured data and transform it into unstructured data. So Postgres is very flexible in these terms. There's a massive documentation page about all these things. I'm not showing everything because it won't last probably a couple of days. I will require to show you. Probably you will want to kill me at the end because it's just too much things. But this is just to give you an idea how much you can do with Postgres. And this is the JSON test functions, a new functionalities added in Postgres 17. I can test whether the data is a JSON. I can test whether the data is a JSON array or is a JSON with unique keys. And then I get a Boolean result on the values. So it's very efficient for filtering also my data. There's also another function, I forgot to add it, is the JSON strip nulls. If I have a JSON object cluttered with nulls value because something has been removed but not the keys, that function can clean up your JSON on the fly and return a very clean JSON out of, so remove all the keys that has null values. I used it in the past and it's very, very efficient. And now let's go to the last addition, the last improvement added in Postgres 17, the JSON table. It's very interesting because when I first heard about JSON table, I thought, okay, I put this thing into the select list and I get the table. Wrong. I put this thing into the from list because getting the data and laterally joining this table to this other one transforms the JSON data into a real table. So I can refer all the columns defined here. I can define my columns are data, are ordinal, as different ways. And then I can just select them. And also I can use the function for filtering the data into the where condition, completely free. In this case, I'm just using the $.childs. The format is similar to JSON path. It's exactly the same on JSON path. So you have to specify the path to access into your JSON object. I specify the columns. This is a virtual column for ordinality. So this number is automatically incremented over the values found into each row. And you see 1, 2, 3, 1, 2, 3, 1, 2, 3, because each row has 3 childs. But also, I can specify the parent name. I can also give wrappers to my functions. So in that case, I'm asking for childs with the star within the array. So I'm returning exploded values within from the array. But because I added with the wrapper, it's just returning me the wrapper into Mary, Lucy, John, and is giving me the information I need, Thomas Green with the address and the list of the childs, completely wrapped into a very clean SQL. Now, let's talk about Sadaharu. This is the demon dog of Gintama. Basically, some consideration about MongoDB, because the main competitor of this thing is MongoDB. MongoDB is a great product, but it came through some controversy recently, and I focused on just on 2 big things plus one my personal bias. But I'm a DBA, so bear with me. I'm from SQL, for SQL, not the rest. So please bear with me. The problem with the MongoDB, well, license. The license with MongoDB, it used to be an open source approved, but then in 2018, it changed to the server-side public license. And this license was first submitted to the open source initiative, then it was withdrawn, and then at the end, when also Elastic adopted this thing, the OSI released the statement and said, no, this is not an open source compatible license. It's just a Fox Pen source license because it puts restrictions on top of the users. So be aware when you use this thing. In any case, you have no distributions that give you Mongo as part of their distribution because it clashes with the GPL basically. Another thing, and this is something I spotted a few months ago on Mastodon, is this, deprecations. This guy was desperate. He said, wow, I used Mongo because I wanted to test new stuff, but now they are deprecating an important part of the SDK that I'm using, and now I'm reverting to Postgres just because I have no other choice. What happened? Well, 30 September 2024, MongoDB removed all the Atlas device SDK from their code base. And then all the mobile apps kept in sync with Mongo stopped to work. This is not nice. So beware also that relying on something heavily corporative may have some issues. And this is my personal bias. I prefer this form for querying stuff rather this thing, honestly. Plain English, basic English is, in my personal opinion, more understandable. But of course, there are people that use ORM, they love the other form. I respect them, but don't ask me to use them. I don't like them. And speaking about Mongo, how can you use your existing ecosystem? Well, I will show you a couple of projects, very, very interesting. The first one is FerretDB. It's basically giving you the compatibility layer for Mongo on top of PostgreSQL. So you install FerretDB, you get the Postgres with all the JSON stuff on the bottom, and then you can continue to use your Mongo syntax on top of it and use your drivers from Mongo. Just replace Mongo and use it. Very nice. But also there is Microsoft DocumentDB. That was a lovely surprise. No Microsoft? Oh, come on, come on. I know. But honestly, I have a lot of friends that work from Microsoft, and now Microsoft is doing a very excellent job for contributing to Postgres. I'm not paid by Microsoft. I'm not paid by Microsoft, but and this DocumentDB is quite interesting because it's still using Postgres as a backend. It's an open source thing, and you can use it for storing your documents. So, quick wrap up. I have a few minutes left. So, wrap up about this final talk of the day. PostgreSQL. Why using PostgreSQL? It gives you a constantly improving ecosystem. It relies on a community effort. There's my friend, Stephanie Janice-Stolting. One time she said, Postgres, it doesn't have a community, it's a community. And that's the truth, because in PostgreSQL, we have a common effort on making a great product, not driven by commercial reasons. We build up the best possible things, and we strive for having this. I'm not a developer, I'm not a C developer, but I do my part in a different way, like today, promoting PostgreSQL. The license is super permissive. BSD license, derivative. So basically, you just need to, you can also, and this happened with Enterprise DB, for example, EDB, they have their own closed source Postgres. They can do it because the license allows that thing. They take PostgreSQL vanilla, they adapt for working as a compatibility layer for Oracle, if I correctly remember, and then they can sell it without any problem. But they contribute and give back to the Postgres project. It is a very good and nice thing. And also we have projects that are improving and extending Postgres. I haven't mentioned it yet at all, the fact that Postgres has extensions. So the one I told you about CitusDB is just an extension. Create extension, CitusDB, create extension, something else, and Postgres extends to other stuff and new functionalities. But remember that your mileage may vary. I guess the Italians will get the joke immediately. This is probably the best car ever made, the Fiat Panda. But what it says, the stickers here, no airbag, we die like heroes. We don't need the airbag. So beware that your mileage may vary. So it depends a lot by how is organized your JSON, how is your workload. So don't take this thing as the truth. I'm just giving you a starting point, and I want to give you an idea on for a foundation for writing and building stuff. Now, if you love PostgreSQL, and this is a little promotion, the 25th September 2025, there will be the PG Day in Napoli, and I'm organizing it. So I am into the organizing. So if you have, at the moment, we have the call for paper open. So if you want to submit, please do. It will close in June, 16 June, if I correctly remember. And this guy is called Ciruzzo. Is the name from, is a very particular mascot I wanted to have. Is the blue elephant dressed as Pulcinella and is playing with the strumolo, a traditional game from the Neapolitan Scugnizzi. And that's it. Don't forget to share your feedback. And that's all, folks. Any question?
Thank you so much, Federico. Do we have any question? We have a... Oh.
Thank you for the talk. I have a small question about the initial difference between the JSON and JSONB structure. I didn't understand why in the first implementation they were actually validating also while reading. I didn't understand why.
So this is a structural thing about PostgreSQL. The data stored into the data page on disk is called datum. So it's a completely abstract and unknown data type. When Postgres reads the data in memory, transforms automatically the data into the actual data. So if you have a binary representation like JSON, there's no necessity to validate it. If it's a JSON, it's a normal plain JSON, then the subroutines for validating kicks in automatically. That's it.
We have time for one other question.
Maybe not related to the JSON support in Postgres, but generally as a Postgres export. Can you elaborate what's the current state of, like if I want to have a Postgres HA deployment, like active, is that a problem still?
Active, yeah. I think the Postgres 17 added the sort of bidirectional replication is based on logical replicas, so you have to deal with conflicts. The drawback, there are two drawbacks, basically. The logical replica is based on database, so if you have multiple databases that you want to synchronize, you have to do it database by database. And there are not yet the DML in, the DDL decoded in logical replica. So if you change the schema, you have to do it on all your nodes, otherwise the replication will break. This is the only drawback. Other active, I'm not aware of different.
I mean, I agree Postgres is the best, the pinnacle of databases, but like its major draw point is like no easy active setup.
I know. I think there are some implementation. I think the biggest problem is caused by the lack of the DDL in logical replica. That makes a massive pain in the back. Ironically, I've written a replication tool for MySQL to Postgres, and I can easily replicate the MySQL changes into Postgres, even transforming the dialect for the DML, the DDL, but I cannot do Postgres to Postgres. So it's so disappointing. So I'm waiting for this thing from Postgres 9.4 and still not there yet. So if you are a C developer, please do it, because we need it.
Thank you.
And thank you so much, Federico.
Thank you very much.